it before you need to leave. I am Pedja Klasnja. I'm an associate professor in the School of Information here at Michigan, and I've been part of the Mobile Health Training Institute for quite a few years now. And usually I give a talk on user-centered design, and so to the use of UX design in creation of engaging interventions. But this year, my colleague Mark Newman will be taking over that talk, because Vivek asked me to talk to you guys about how to think about the architecting of the systems that you need to run mobile health studies. And I've been, for the last few years, I've been working on a couple of different systems that are pretty sophisticated in terms of what they're able to support. And we've been bitten by a lot of different kinds of bugs. So he wanted me to try to condense some of that experience so that, into the lessons that you might want to take in terms of how to think about what platforms you decide to work on. And so that's what I'll be talking about today. Just before I start, I want to say that both Mark and I are going to be available at the end of July for an Ask the Expert session on user-centered design. Apparently, there is a dress code for School of Information at University of Michigan, so both of us will be wearing very similar gray shirts or something like that. And so that's going to be at the end of July, but also I'm happy to answer any of the questions around these technical infrastructure issues that I'll be covering today. So just to set the stage, I want to start with this quote by Bill Buxton, who is a very famous interaction designer, who said that basically design is always compromise. And what he meant by that is that whenever you're making design choices, you're always making trade-offs. And really the goal of a good designer is to come up with a set of trade-offs that you can live with, right? That fit the purpose of the system you're building very well, while taking into account all the various constraints that you're dealing with when you're in a particular design problem. Arguably, this is the case for life in general, right? For any large decisions we make, what relationships to be in, what career we choose, and so on, it's all these trade-offs. But I think for the purposes of today, what's important to note is that this very much applies for picking of infrastructure, right? There are different ways you can go with deciding on what platform to use. And each one of those decisions will come with both some advantages as well as quite a few disadvantages. And so the trick is to figure out, again, sort of what can you live with, given the trade-offs that you need to make, what are the advantages and the disadvantages that best suit the current situation that you're dealing with. And really, my talk today is intended to give you some options of what is available in terms of what kind of architectures you can pick and what those trade-offs might be. So what I'll be covering is first just giving you an overview of what broad types of solutions are available. And then we'll be going to the trade-offs for each one of those. And then at the end of the talk, we'll be talking a little bit about what kind of considerations or what kind of decision-making you need to be doing when you're deciding where to go. So just very broadly, you can think of basically on the software side, there being 4 large classes of platforms that you might be able to use. One is you can completely rely on commercial software. So the off-the-shelf tools that are available that you can put together to try to meet your objectives. Another way that you can go is to hire a company like Fitabase or Pillar Health or Care Revolution that basically have their own internal platforms for running behavioral and health studies, and they can sort of add some custom code to create a solution that might be a good match for what you're trying to do. And we'll be talking about the disadvantages and advantages of all of those. A third class of solutions is if you actually start with some commercial pieces. So you might want to start with something like Fitbit or MyFitnessPal or something like that, and then layer some custom code on top of that to add additional functionality that you need that a commercial software does not have. And then finally, you can just sort of write something from scratch, right? You can build your own infrastructure that is going to exactly do the things that you want it to do. On the hardware side, I will spend a lot less time just because you guys saw a talk on sensors relatively recently. But really, the way to think about this is also that you can either sort of rely on commercial sensors, activity trackers, glucometers, things like that. You can pair with people who build their own custom sensors, or you can do some kind of a combination of both of these, right? And we'll talk a little bit about how to think about that as well. So how do you make these decisions? Well, let's talk through some of the advantages and disadvantages of each one of these strategies. And let's start with commercial software. So these are basically tools that are available off the shelf. So they're basically, you're buying a software product or you're just using it for free if it's available. And you're going to be putting together a solution that involves only the things that basically don't involve any coding, right? And so there are a bunch of different things you can use for that, from the things like Fitbit and Garmin systems that give you a sensor and some intervention pieces that are already baked into their applications. There are a number of software solutions for doing things like in mental health space. So this is a screenshot of Headspace, but there's also Insight Timer and a bunch of different ones. You can also use various kinds of survey software. So in this particular case, there is a screenshot of Qualtrics, but you can use SurveyMonkey, other things of that sort. You can use services like TextMagic and bulk SMS that are used to send notifications and messages in bulk, as well as various kinds of forums and groups like Facebook groups, if you need to have some kind of a social component. Right. And so what can you actually end up doing with something like this? Well, the one thing that I actually want you to really take away from this is that you can actually build up pretty sophisticated experiences using just off-the-shelf software without doing any coding whatsoever. So these are just some of the examples of things that I have been involved with lately. Noreen Watson, who is at Fred Hutch Research Institute in Seattle, has been working on an SMS-based system to support smoking cessation and engagement with their web-based platform for smoking cessation. Billy has been working with her as well. And currently, the version of this that she's using is really just using off-the-shelf SMS engine to both send messages to people and also do survey work as well. A former student of mine, Sonali Mishra, is currently working on a study where we're basically wanting to send people messages to prime their expectations that they will have positive experiences when they exercise. And that is using a Fitbit as a tracking system so we can get physical activity information. We're sending the actual intervention messages using text messaging a system called TextMagic, which is just allows you to upload a spreadsheet with phone numbers and messages, and it will just sort of do that for you. And then she's doing surveys through Qualtrics. And again, this is basically all being done without any coding whatsoever. Another project that I was recently involved in is it's a randomized control trial that looked at this instrumented toy to help children with emotional regulation. But the actual infrastructure for the study itself was purely done in Qualtrics. So all of the data collection was done in Qualtrics. The survey reminders were set through Qualtrics. Qualtrics also had some functionality to allow you to send adherence prompts. So if someone has missed a certain number of surveys, you can send reminders. And so again, there's sort of an off-the-shelf product with very little sort of glue that was needed to be added to make this work. And then finally, there was a project at Kaiser Permanente that a colleague of mine, David Arterburn, was running, where they wanted to really combine some of the traditional approaches to diet that includes logging and sort of tracking diet with more mindfulness-based approaches. So they combined both MyFitnessPal and a system called Eat Right Now that was developed by Judd Brewer over at Brown, which is currently a commercial company. And then they used this system called Coachific as a glue for the whole thing. So basically, Coachific would get signals both from MyFitnessPal and Eat Right Now, but then they were also able to provide sort of coaching by one of the dietitians at KP through the Coachific platform. And again, so pretty sophisticated intervention using only the pieces that are off the shelf without the actual study staff and a research group having to do any programming to make this work. So what are the advantages of going this route? Well, one is that you're really starting with something that is highly polished and usable, right? So these companies spend a lot of money building products that are well refined, and so your participants would have a system that is really well, that works really well, where most of the bugs have been fixed, and that is going to, if you have a longitudinal study, evolve over time in a reasonably clean way. So when iOS, the new version of iOS or Android comes out, these commercial software pieces typically get updated very quickly. And so you're never left in a situation where the thing that you have is no longer working because something changed in the underlying platform. right? There are also relatively low requirements for technical expertise. A lot of the things that you need to do as a researcher is really more configuring than programming. So you need to configure surveys, you need to schedule SMS messages, things like that. The one exception to that being is that if you're using things like Fitbit, you might need to have a really lightweight application that will download the participant data through the Fitbit API or something of that sort, right? But really the technical lift for that is substantially lower than if you went with one of the more custom solutions. And finally, since these things are already built, right, they tend to be more cost effective for you as a researcher, right? There's certain things that are free, other things have relatively low per user fees. So, you know, something like $5, $10 a month per participant, or you're just paying a fee to access the API and that can be a still bulk amount that is not that high compared to other ways of going. What are the disadvantages? Well, one is, and this is really an important one to keep in mind, is that you have basically no control over the update schedule of the system, right? So features can change midway through the study, and it might actually quite meaningfully affect what that experience is like for participants without you having any control over it. And so this happened to a group at Dexel, where they were running weight loss studies using Weight Watchers program, and then halfway through a year-long trial, Weight Watchers completely revised how the system works. Right, this can be a pretty serious issue to deal with. But also, and I think this is the thing that people hit very quickly. Often the functionality doesn't really line up exactly with what you need, right? So Qualtrics does not have any sensor-based triggering. So if you need questionnaires that trigger off of different kinds of sensor streams, none of the sort of off-the-shelf solutions might be able to do that particularly well. There might be certain kinds of interventions that you're interested in. So let's say adaptive goals, how adaptive goals work. But the ones that are available in commercial software might not be actually the kind that you care about, right? So Garmin has daily adaptive step goals where the goal changes every day. But if you're actually interested in a different kind of algorithm, then studying how Garmin does it doesn't actually line up with your science, right? There's also the fact that often you have to combine multiple tools in order to put together an intervention that you actually want to study, right? And so that increases the complexity for participants. Often you also end up with duplication of features, right? So if you're trying to let's say, put together a weight loss intervention of some sort, right? And you really like how MyFitnessPal deals with tracking, right? They have pretty sophisticated tracking system. You might decide to use that while you might have something else for physical activity. But often these applications actually have features that cross over, right? So MyFitnessPal will let you track physical activity as well, and Fitbit will let you track diet poorly, but it will let you do it. So then participants can often be confused about which ones they're supposed to be using and how these various pieces that are duplicative in nature relate to each other. There's also the fact there's often very little information about the underlying technology, right? So if you have some kind of, let's say in the case of Fitbit, they have these classification algorithms that take the raw data that their watch is collecting, and they turn that into bouts of activity. So a bike ride or a session of elliptical trainer and so on. You have no access to those algorithms. You can't fix them. You can't make any changes. And so you get what you get, and you're not going to complain, right? That's basically how things work with these commercial systems. Similar kind of things for recommendations that are based on sort of the person's previous activity and so on. So whenever you have an algorithmic component to these commercial systems, you will typically have very little information about what's going on. And then, of course, there's often a need to aggregate data from multiple sources, which can be sometimes tricky if you don't have some kind of a unique piece of information that is spread out across all of these systems, right? So each one of these commercial systems might have their own API, and there might not be any unified way to pull all of the information into one place except for going to each individual API separately and downloading your participants' information and then trying to figure out who is who, right? And also then for the kinds of stuff that Billy was discussing in her last talk, for these more advanced experimental designs, for factorial experiments, for micro-randomized trials, for doing smarts and things like that, very rarely do you get that kind of functionality built into these commercial systems, right? So if you're trying to do something like that, that is sometimes possible, but you're the one doing all of the randomization, right? All of this stuff has to be done manually. So in the case of that expectation study that I was just mentioning, Sonu is actually doing a micro-randomized trial with that, but she has manually randomized exactly how these prompts are supposed to be sent, and then she uploads that into TextMagick for those messages to be sent, right? So you end up doing a lot of the work that typically a computer will do around randomization. Okay, so the second option that you have are what I'm referring to as white label solutions, which is basically there is an increasing number of companies that have some kind of a platform for running studies. Many of them started in the EMA space, so they built platforms for running ecological momentary assessment systems, and they will let you basically run use the system that they currently have, as well as often they were willing to write some custom code on top of that to make things work for what you're trying to do. And so here are a couple of examples of what that might look like. One is a study called Valentine that one of the scholars this year, actually, Jesse Golbus, is running at University of Michigan, which is a physical activity intervention for patients after cardiac rehabilitation. And they're using a system called Care Evolution, a system called Arcade Studio by a company called Care Evolution, which basically is a data aggregation platform where they're able to pull data from surveys, from patients' records in the EMR, and from some of the sensors like Apple Watch and so on, as well as then send participants push notifications. So in Jesse's case, they're using an Apple Watch or Fitbit to track activity. They're integrating with the patient's electronic health record in the hospital system, and then they're using the Care Evolution system to send notifications with interventions. Another example is a study that is run by Stephanie Goldstein, who was a scholar 2 years ago. She's now a faculty at Brown, where they're trying to basically increase the adherence to dietary prescriptions by trying to make predictions about when a person is likely to lapse, and then if it looks like a person is likely to have a dietary lapse, intervene in the moment, right? And so what they're doing is they started with a system called Pillar Health, which is an ecological momentary assessment system, and then they added to that a custom algorithm that they're using for prediction of dietary lapses, as well as they're sending prompts that are micro-randomized via SMS. And so here, what happened is that since Pillar does not by default support things like micro-randomization, there was some kludgy ways that they had to go about doing this, where Stephanie had to write a whole script for how the micro-randomization was going to work, and then Pillar just sort of used that to do the actual sending of the SMS. So what are the advantages of going a route like this? Well, one is that you have software that is also professionally written and maintained, right? So the quality of the software is typically going to be pretty high. The second piece, which is also really important, is that you have someone to yell at when things are not working, right? Because you're actually contracting with these small companies that whose whole business is to help researchers run their studies. They tend to be really responsive to reports of technical issues, and they're pretty quick to resolve issues, right? So you have someone that you can actually talk to, which is a lot easier than trying to figure out with Fitbit if you're finding an issue with a system like that, right? You can also layer on top of the infrastructure that they currently have some additional functionality that will typically cost more, but the overall the cost effectiveness of these systems can be pretty high. There's also the fact that you actually have substantially more control over the overall user experience, right? You can decide what exactly you need, and they will help you sort of massage their infrastructure to creating the experience that you're trying to get for your participants. And then data aggregation is handled by the platform itself, right? So this is really huge, right? They will suck in all of the various streams of data, whether they're surveys, whether they're sensors, whether they're sort of interactions that participants are having with their app, and they will sort of aggregate all of that data and just give you these the data that is ready to analyze. And then finally, so a big part of what these companies offer are tools for monitoring your study, right? So they have various kinds of dashboards, they have various kinds of reports that make it easy to sort of manage participants, as well as to see how things are going, adherence rates, what surveys people are answering, which ones are not, and so on. So all of this kind of stuff you end up getting pretty much as part of the basic service, and then you just end up needing to pay extra money for any of the custom functionality that you're trying to build. So what are the disadvantages? One is that often these things are written by small companies. And so the resources that those companies have end up being prioritized towards engineering. So building new features, fixing bugs, things like that, versus design. So you can end up with systems that have less than optimal user experience just because they're designed by engineers. And so they work okay, but it's not going to be nearly as polished as sort of a large commercial company that's building an intervention in its own right. You're also often limited by what the platform itself is able to offer, right? So if there's no support for sensing in a particular EMA engine, you're not going to be able and do sensor triggered EMA, right? It's just that becomes a lift that is probably too big for them to do just for your project, right? And then if you're trying to do anything more custom than what the basic system is that they're offering, that can end up being pretty costly very quickly, right? So because they're starting to write a lot of custom code that might not be reusable for other people that they're trying to provide service to. And so that ends up being charged in the same way that as if you were going to just a standard software developer or the software developing firm. And so it can get quite expensive. But there's also a more subtle part of all of this, which is that often what they would even agree to do is going to be a function of how closely your project matches where they're trying to take their platform, right? So the way that this works with these white label companies is that they make their money basically by selling infrastructure, right? They can give you a good price for doing an EMA study because they already have all of this stuff built out, right? And so the business model here is that they're basically trying to always prioritize features that they want to include into the core infrastructure, right? And so if what you're trying to do is pretty tangential to where that company is wanting to go, it might not be worth their while to build a custom code for you because they're not going to be able to include it into their core platform and then sell it to other people, right? And so there's a sort of a recent example of this where friends of ours who are running a company called Fitabase, which does really, really good work on supporting behavioral science, but they don't have a mobile app, right? And that's not something they're actually interested in developing. So if you need a mobile app as part of the platform, Fitabase is just not a good match for that, right? Because it's not something they want to spend their resources on, and you would need to look for a different place to do that. There's also often things like what kind of data that a particular company wants to deal with, right? If they don't want to have patient data, like EMR integration might not be possible. There are a number of these companies that really don't want to deal with highly privacy intrusive data like location. So if you need location, then one of these companies might not be a good match for you. And then finally, although this is starting slowly to change, traditionally there was relatively little support for more advanced experimental designs. So things like factorial experiments and micro-randomized trials, those were just not part of the bread and butter work that these companies did. Okay, so the next way that you might be able to go about doing this stuff is through what I'm referring to as hybrid solutions, which is basically you start with something that is commercial in nature, that is mature, and then you add some pieces on top of that to fill in the holes that the commercial software does not offer. And I'll give you a couple of examples of what this can look like. So a few years ago, with my colleagues at Kaiser Permanente, with Dori Rosenberg and David Arthurburn, we did this project called Benefit, which was basically was supposed to be a lifestyle intervention after patients undergo bariatric surgery. And this was all done as part of the quality improvement at Kaiser. So we basically were trying to figure out how to make this, how to build this in a way that would make it most likely that if we find good results, that it can be incorporated into routine care. And so what we ended up doing is we're basically trying to go with as much commercial software as to systems as we could. So we gave people Fitbit, a Fitbit tracker, right, and a Fitbit app where they could do all of the physical activity tracking. They had a breathing scale that was also that they were able to connect to the Fitbit to application, so they could see their weight inside the Fitbit app as well. And then on top of that, we just delivered the rest of the functionality we wanted to provide through SMS messages, right? But we did that by building a custom server that would basically to connect through the Fitbit API to the Fitbit system and get participants' data. And then based on that, we would send people adaptive goals. So every day we would send them a different kind of a goal for their physical activity targets. We also sent them recommendations for what they should be eating based on their surgery date. We sent them custom prompts to remind them to weigh themselves and so on. And all of that was basically done through a custom server that we built that basically participants never interacted with directly. And what that also allowed us to do is to actually have a pretty sophisticated experimental design where we had a 2x2 baseline randomization. So we had a factorial experiment as a sort of basic structure. And then there were several intervention components that were actually micro-randomized over time. And so we were able to actually do both of those because we could build that part ourselves. Another example is the project called Smart 2.0, which is being run by Job Godino at UCSD, which is a weight loss intervention for young adults. And the way that they're doing that is that they're also giving people a bunch of commercial devices. So they're giving them a Fitbit tracker, a scale, an app for tracking. But then there's also sending custom interventions via text messages, all based out of the Fitabase's backend system. So Fitabase is collecting all of the Fitbit data, and then it's handling all of the custom code for doing these interventions that they wanted to provide to participants. So similar kind of setup as we had with Verifit, except that they used sort of the Fitabase as the backend instead of building it completely from scratch like we did ourselves. And so what are the advantages of this? Well, insofar as the bulk of the intervention is commercial, you get all of the polish and sort of the usability of commercial products. But more importantly, from my perspective, is that this going this kind of route allows you to focus your resources on only those things that are really unique to your study and to your project, right? So instead of having to reinvent the wheel of all of the things that's all of this other infrastructure that you have to build just to make something work, right? So in a case of something like a physical activity study or a weight management study, there are a lot of common elements that you have to have. You need self-monitoring, you need goals, you might need social support, right? Building that stuff from scratch is just a ton of work. And there are good implementations on all of that are already available in the commercial space. So you can sort of take those implementations that are sort of state of the science, and then layer on that the kinds of unique contributions that you're trying to actually focus on. So that means that you don't need to duplicate commonly available features. And that you can really focus the limited resources that you have on building out those components that are going to be most directly relevant to the scientific questions you're trying to ask. There's also the fact that this kind of approach often allows you to create projects that are more likely to actually be used in some kind of organizational setting. So in our case with KP, what we really needed to do is completely minimize how much new code that they would need to maintain themselves, right? And so by using this kind of a system of Fitbit app plus text messages, that basically eliminated the need to have a custom app that KP would have to manage. And they could just focus on sending it on this sort of backend system and sending text messages, which they were already using to communicate with patients. And the other part, of course, is that since you're going to be building at least some of the infrastructure, you have a lot more control over the algorithms that you want to include. You can do more sophisticated randomizations and so on. So what are the disadvantages? This list is short partly because a lot of the disadvantages are actually shared with having a completely custom system. So we'll be talking about that in a minute. But the key one is that even with a relatively, what might on the surface seem like a relatively simple set of additions to a commercial system, it can be pretty easy to end up with a lot of custom code that you need to build. right? So in our case, that building out the benefits still ended up taking something like 9 months of a sort of programmer doing the work to build all of that out, right? And so that's still substantially lower than the amount of time that we would have needed to use to build a complete intervention from scratch, but it's not trivial by any means. The other piece is that sometimes the integration of the pieces that you built and the pieces that the commercial might be less than ideal. So in our case, sort of a key example of this in Benefit was that we had these adaptive step goals, and so participants were receiving a different goal every day. But there was no way at the time for us to actually make that goal part of the Fitbit system, right? So Fitbit was still giving them feedback on the 10,000 steps a day default goal, but they would get through a text message an actual goal that they were trying to meet, right? That's not a great user experience, and sort of it can create frictions. That is now solved, right? So you can actually now, Fitbit does have APIs through which you can use a custom goal and put it directly into the system, which is nice. But these kinds of frictions do come up when you're going this kind of hybrid solution route. And so finally, there's the rolling your own solution, right? Building the whole thing from scratch. And often when we think about mobile health projects, that's sort of what we have in mind, is that you'll build a system, you'll build an app. And there's some definite advantages for going that route. One is you have complete control over the experience that you're trying to provide to participants, right? So exact specification of interventions, as well as exact specification of what data you're going to be collecting. You can also, and I think to me, since I come from the user-centered design perspective, and I'm always trying to be thinking about both privacy and user burden, building your own system gives you a lot more flexibility around how you actually collect data, right? So you might not necessarily want to store really sensitive data in the raw form, something like location, right? Especially if you're tracking people's location often. In one of our systems, we're actually tracking location every 5 minutes, right? But what you can do if you have your own system is basically do the classification of those pieces of information that they're coming in. In this case, it might be that you really care about the kind of a place that the person is at. Are they at home? Are they at work? Are they in the park? Are they at the grocery store? Right? You can use something like Google Places API to do a lookup on the location, save that, and discard the raw location if the raw location is actually not that important to you. Right? So there are always trade-offs in sort of how much data you save versus privacy, but you can make those kinds of decisions in a much more informed way if you have control over what's being collected. You can also customize the timing of the prompts, right? So one of the things that we've been playing with is this notion that you want to be asking people questions only when you don't think you actually know the answer. Right. So if you have predictive algorithms in your system, which are taking the self-reports as they're coming in, and they're sort of trying to make predictions on the next self-report, you can only ask for self-report when your confidence intervals get really wide, right? You don't necessarily need to be doing this all the time, right? So that can reduce burden. You can also use different ways of trying to figure out when a person is actually interruptible, right? So if you're working on let's say Android currently, you still might be able to get an information when they're switching applications, so that you might know when they're closed out of a social media app, and that might be probably a good time to prompt them because they're not in the middle of anything all that important, right? And so you can actually customize exactly the timing of when you're collecting information and be very thoughtful about that. It's also, especially as you sort of think about the projects that you'll be working on as part of this training institute, it's a lot easier when you're building your own software to have really true collaborations with people in the technical disciplines, computer scientists, data scientists, and so on, because the technology itself can be a part of the contribution, right? They're going to be building new algorithms, or they're going to be innovative interaction methods that are being developed, and so on. And so having your own tool allows you to actually add those in, and for that project to have both the health science and behavioral component, as well as a strong technical component as part of the contribution. And then finally, insofar as you're interested in these optimization designs, right? When you're building your own infrastructure, you can randomize anything you want, right? So it becomes much easier to have really sophisticated study designs where you're sort of layering levels of randomization. So you have a factorial experiment, and you have micro-randomized trials that's layered on top of that. You might even have sort of some sort of multi-arm RCTs going on at the same time. Whatever makes sense scientifically is actually substantially more easier to do when you're building your own system. But there are also a bunch of disadvantages. One is that complexity and cost of all of this is really high. There's no way around that. And that's the case whether you're going with a commercial company to build your code, whether you're just hiring a staff programmer, or whether you're trying to get this done with students as labor. There's going to be a lot of time involved in getting it built. There are going to be bugs, and it's going to be expensive. That's the nature of this game. You also, and I think especially for those of you who are coming from medical and behavioral sciences, it's really important to understand that even if you're having a professional programmers building the code for you, it is very useful to have technical expertise in your research group, so to communicate with developers and to sort of solve problems and be able to make decisions about if there are things that can be implemented in multiple ways and there are trade-offs involved with those, to have someone who can actually manage and navigate those conversations, right? So it doesn't completely eliminate the need for technical expertise, even if you're going with an outside company that's charging you a ton of money to build your system. The other piece that often ends up being the case is, except when you really have very, very large resources, is that the quality of the code ends up being low, right? Because first of all, you're building just a lot more code than with any of the models so far. Often that code ends up being written by students or individual programmers. And that means that there's just a lot fewer eyes on the code, right? So the formal testing ends up being shortchanged. There's often few formal code reviews and so on. So the quality of the code is going to be very different than when it's being developed as part of an infrastructure that is being managed by a commercial company. And lastly, it's really important to understand that even when you're building your own code, programming in 2021 is all about reusing third-party libraries and third-party pieces of code. So dependence on other code is still there, even if you're building something for yourself. And I will be coming back to that in just a second in terms of what the implications of that are. And then finally, it's often you're actually building these things with limited resources. And then what ends up happening is that you often prioritize the actual features that you need to be able to run your study. So whether that's intervention features or data collection features. And all of this sort of infrastructure for monitoring studies ends up getting shortchanged. And we are currently in the middle of a study where that was absolutely the case, partly because we just had one person who was writing the code and there was just constantly new features that needed to be built, new bugs that needed to be fixed. And so that all of these dashboards that are so important for running high quality studies just sort of end up taking the back seat. So what are some of the sort of concrete perils that you end up dealing with when you're going this route? One is that, and this has happened in every single project that I've ever worked on, things end up breaking even when you haven't changed a single line of code. And this can be due to a number of reasons. One is often that the underlying platform updates will break something. So the most recent example is in the study of the system HealthSteps that we're currently running. There was a minor update in iOS that went from whatever it is currently, 14.3 to 14.4, or whatever it was. And it broke the in-app browser windows that we're currently using to authenticate Fitbit when someone is onboarding. And so onboarding just stopped working. Similar kind of things happen with APIs. So the very first time we built this system called HealthSteps, we were using Google Maps as part of the onboarding process to help someone put in where their home and work address are. And halfway through the recruitment, Google changed something with absolutely no documentation, and that piece just bombed. And the whole application crashes when the person gets to that step in onboarding. And our programmer at the time literally didn't sleep for 48 hours trying to figure out how to both find out what the bug is and to resolve it. These things happen, right? Another kind of thing that sometimes happens is that some third-party library that you're using as part of your code ends up changing its sort of business model. And some of the features that you're using that used to be free, all of a sudden they become a paid tier and you don't know about it, right? And it just sort of silently stops working. And in our case, there's a push messaging library that did that for some of the information that they send back to the server, these read receipts. And we just at one point stopped getting this information. The system still works, the message is still being sent, but you're not getting some of the information that you need to get back. There's also more drastic versions of this. A colleague here at Michigan, Mike Dorsch, who works in sort of dietary space for hypertension, built a system that used some of a third-party library called Neura for doing a lot of their sensing. And initially, when they developed their system, that was free. And then relatively recently, Neura started charging $5,000 a month for that functionality which was previously free. Completely different ballgame, right? All of a sudden, your project can absolutely not deal with that, right? The other thing is that and these are sort of minor details that we've gotten bitten by. A lot of this with modern mobile programming, a lot of the features end up depending on some form of cryptography, either certificates that are being issued by Google or by Apple, or sort of code signing or things like that. And a lot of those things end up expiring, right? You can sort of think of them as contracts that last for a year or however long, and then that you need to renew it. If you don't catch it in time, some piece of the software just stops working, right? In our case, we had the recent situation where the push notifications on iOS stopped working for a couple of days until we sort of realized what was going on and uploaded a new version of the certificate. So these kinds of things just kind of break your system, even if you're not actively touching it, right? And so it's really important to have a way of keeping close track of what is happening with the study and what is being done. And that is often, and this is sort of the last bullet point that I want to make here, is that often the sort of just running the system yourself, or having a group of beta testers or a group of researchers who are continuing to run the system as the participants are running it, is actually insufficient, because the experience might look okay while certain things on the back end are breaking, right? Whether you're not getting certain kinds of data or the randomizations stop working the way that they need to work and so on. So it's really important to actually have all of these study monitoring tools that allow you to monitor your study in a systematic way. And that, again, is a pile of work that needs to be done in order to build those things out. And then things like, that a lot of this functionality depends on the functionality of the operating system. So, iOS will kill certain applications if they have not been used in a while. So if you have a sensor that is connected with some kind of a third-party app, whether that's Fitbit or whatever the app that comes with your glucometer, right? And someone is using Facebook a lot on their phone, eventually the memory needs for the phone will force quit the applications that are currently asleep, and those sensors stop communicating. And so there's a lot of sort of data missingness that end up happening with these kinds of custom solutions that can be pretty tricky to try to understand what exactly happened, why the data stopped coming in, and to try to troubleshoot as the study is going on. So how do you make these decisions, right? So to what gave you a bunch of sort of trade-offs that happen with each one of these things, and sort of what are really the questions that you should be asking when you're making these decisions about what kind of platform to use. So very briefly on the hardware side, again, you've had that talk on sensors, so I'm not going to repeat all of that, but it's really important to understand that hardware is super hard, right? It's getting a new sensor to work in the lab under ideal conditions is still hard, but doable. Getting it to work equally well once you put it into the field with all of the variability of the placement on people's bodies, on the weather, and all of this other stuff, and getting reliable data can be really, really hard. So it's really important to keep that in mind whenever you're dealing with or you're trying to consider custom sensors, right? The other piece about hardware that I think is really important to keep in mind is that hardware ends up having a disproportionately large effect on the experience that your participants have in the study. Because it's attached to their bodies, it's attached to their clothing, they have to wear it, right? And so flaws in the hardware, if the hardware is big, if it's bulky, if it requires a lot of charging, all of these things end up registering to participants as burden in ways that are substantially higher than sort of bugs in software. Bugs in software are annoying. And if they persist for a long period of time, people will get disengaged. But hardware that is not highly usable ends up being sort of like a mosquito that's constantly buzzing around your head. It's really hard to ignore. The other question is that you always want to consider is like, what's the data that you actually need? Like there's a lot of data that would be nice to have, but that might not be always the things that are absolutely essential for the kind of study you want to run. And so you always want to be weighing what's essential for you for the science that you're trying to do versus what is a nice to have, and making decisions appropriately. Do you need raw data, right? Or are these inference data that have already been classified by commercial sensors enough? How important is it for you to know exactly when you're going to get the sensor signals, right? So if a lot of what you're doing are highly precisely timed interventions, going with a custom sensor over which you would have a lot more control over the timing of communication might be a necessity. And then in terms of, again, thinking about user experience, often there's sort of parts of the project that can be done with either commercial sensors or sensors that are highly privacy preserving, right? Accelerometers, things like that, right? And the question is, can you build your intervention, or can you build your data collection system in a way where some of the more advanced stuff that might not be quite as essential to the project are the things that require either the custom sensors or more privacy invasive sensors, and those can become things that people can actually opt into and then get some additional value in return, right? So thinking about sort of gradations of functionality, and those gradations of functionality being tied to particular kinds of sensing streams that you're trying to collect. On the platform side, I'll repeat what Billy asked you 15 times in her talk, which is what exactly is your research question, right? That has to be driving everything. And so if your research question is really about sort of the framing of messages or the content, or you probably have a lot more freedom about how you deliver that message, right? And you might be able to use some of the more commercially available systems. Then if your science is really about these sort of nitty-gritty details of delivery and presentation, in which case you might want to write it yourself, right? What is the stage of research you're at, right? Often you can get some checks on the concepts and the basic ideas just by through commercial systems that you customize, but sort of when you're trying to do the fully fleshed out intervention, you might need to do a lot of this building yourself. At the same time, when you're doing something with 15 or 20 people, right, in a smaller pilot study, those kinds of studies are a lot easier to do with software that requires a lot of hand-holding and a lot of bug fixing along the way, that if you're trying to do that in a trial with 500 people, right? There you really need bulletproof software. And so that might push you towards hiring a professional software development firm, or using one of these platforms like Database that already have a platform in place. And then, of course, it's all a question of resources. The more custom code you have, the more expensive it's going to be. The other pieces, of course, is to what kind of technical expertise you have in-house, and whether you can actually manage students and programmers who are doing the work. And finally, is this really is it a health science project, or is it a truly interdisciplinary project that is going to have a large component of technical work? Because those are going to lead you likely to very different paths in terms of how you think about your infrastructure. And so the more technical innovation is going to be, the more likely you're going to be moving in the direction of custom code. So I'll stop there, and I'm happy to take any questions. Thanks for your attention.
Pedja, that was a lot of wisdom from the school of hard knocks. Those of us who work with these platforms will understand all the content. Having said that, I want to remind the scholars that he is also accessible via his consult room. I strongly recommend those of you who are involved in the trenches with clinical studies to tap into his wisdom. I do for my own studies. And are there any questions?
I think I have one quick question, if that's okay, Vivek. Just I know we're over time.
No.
I think I was definitely kind of surprised when you talked about like the example of Nora, like, that the cost could change and it was free and then it became costly. Because I feel like, at least my experience is that if you have a contract, it's kind of binding for the duration of the project, right? Like if it was free and then become costly, yeah, how do you actually adjust for that? Do you have to have your legal or your contracting people involved just to make sure you're covering all the bases? I guess how can we avoid it in the future, I guess, if possible?
No, that's a really good question. So with a lot of these third-party libraries, there are actually no contracts, right? You just sort of, you either download the system or using an API. So it's not a formal contract between two companies. That's part of the issue, is that they're sort of providing a service. I mean, think about something like Google Maps, right? There is an API there that you're able to access, and you're not having to sign any papers with Google to do that. And if at some point Google decided that API is going to cost $10 a month, right? There's no contract breach in doing that. And with a lot of these third-party systems, that's the flavor of how these things work, right? So that you're, and many of them have free tiers. And so often the free tier, at least when you're starting the contract, when you're starting your project, is actually all you need for the functionality you're trying to get at that time. But if what the free tier contains changes, that can catch you midstream.
Got it. Okay, I think that makes perfect sense. And I wonder if it's even if that's what they're usually doing at the contract for a company like not Google, right? Like something that's more manageable or smaller scale. Should we even try to be more proactive and just letting them know that we want to do this specific project and we wanted to have like a more of a common agreement? I don't know even if that would fly or not, but I'm just like thinking maybe that can help to prevent at least an issue like that in the future. But
yeah, I think anything you can do to communicate, especially with some of these smaller companies, right, that would give you some information about where they're heading over the duration of your project would be super helpful, right? So sometimes they can't actually say, right, because some of these changes are tied to either going public, or there's sort of a lot of this. That's a lot of problems with startups have to do with that. The roadmap is not public, right? There's certain what they have published and what's available is some version of that, but it's really hard to get information where things are going to be 6 months from now. But I think contacting people and just asking questions is probably the prudent thing to do across the board whenever you're including at least these commercially based third-party libraries.
Thanks again, and great talk. Thank you so much.
Wonderful. Are there any other questions? Great. Pedja, thank you again.